Because of colors, no, it'll be easy to understand. That's why I'm just picking up the colors. Okay, now this is the pulse. So what is the pulse? The pulse is like this. Huh? First, which particular part of the pulse will strike the wall? Yellow color one, and there's a rigid in. First, yellow color will go and strike, then the blue color one, then this one. So this will get inverted. This will become erect. These are erect after reflection. This will become inverted. So we'll go for plotting that one now. In exam, all possibility of asking questions of this kind also. Okay, I think everyone is able to understand now little bit easily. If you want, you write it P1, P2, P3, P1, P2, P3, and the wave is. Okay, no problem. You may expect questions of these kind. There is no any you can say formula something. What teacher has taught that you should able to apply it. When a wave arrives at a rigid end, it will get reflected and will be inverted. Now, similarly, the same pulse, let it approach the free end. First, we will strike the free end, the P1. It's not a drawing competition. Huh? They're just so that it'll be easy for you to understand. That's why I just spending some time on these things. So this is the P1. So when a pulse is reflected by a rigid end or free end, what will be the shape of the pulse? I think now we need not to bother on shape of the pulse. Okay, got this? It's not that only some curved one. It should be, let it be whatever be the shape of the pulse. We can predict what be the shape of the pulse after reflection. Any doubt you can clarify? Completed. Okay, let's go for the sine wave, because see, this is the diagrammatic representation, but practically what we are more interested on the sine wave, no, with the transverse wave when propagates on a rope, the shape of the rope will be like a sine wave. We are interested on that one. Let's see the, if incident wave is a sine wave, what will happen to the reflected wave? I may not be able to draw diagram. The first thing, y equal to a sine omega t minus kx. The pulse will approach here. So when it is reflected from a rigid end, what will happen? When it is reflected from the free end, what will happen to the wave? First, reflection from a rigid end. I think I'll go for reflected from rigid end. Don't go for drawing diagram. Huh? This will be very difficult for you. Reflected from a rigid end. Okay, no. What will happen when reflected from a, after reflection, it will move towards left. So in place of x, what you are going to write? Minus x. And it will acquire a phase change of pi radian. So the reflected wave will be y is equal to, so this, if you solve further, what is sine omega, sine theta plus phi will be minus, this is a wave equation when reflected from the rigid end. Got it? Similarly for free end, we'll see what will happen. Y is equal to a sine. Direction of motion will change, no? So therefore what we should write? Incident wave, incident wave moving along. It is understood. The what is this wave moving along positive x-axis? Agree this? Omega t minus kx, if I write, I think it is understood. So if you write it moving along positive x-axis. What about this? Reflected wave moving along negative x-axis. Okay, this is what happens to the wave. Now, similarly, let me take the moving along positive x-axis. What will happen to the wave when reflected by rigid end? So you don't do anything, just put, what is the method I shown? Okay, as the reflected wave moves along negative x-axis, put minus x omega t. Since reflected by rigid end, a phase angle of pi radian. Am I right? Then this will become minus. Try to look at once. What will happen to reflected wave? It is in what direction it is moving. Will it be inverted? So that's what I think some mathematical trouble will come for you. Yes, we have taken care all. Don't think that it is not inverted. It is inverted, but mathematically what happened? It has taken a equation of a sine kx plus omega t. But like a minus sign should come and reflected from rigid end. So because of maths, you see, the sine of minus theta minus and minus of minus, this will be plus. Got the idea? Now let's come for the free end. Minus kx. Okay, this will be because due to reflection by free end, no phase change. So pi radian I'll not introduce. So this will be very troublesome for students. Like so free end negative is there, rigid end no negative sign is there. Through mathematics it has arrived like this. This is what happens for you. You pick up the questions, no? Rather than fighting in the question, better learn the method. So the wave is moving along positive x-axis. After reflection, what is this wave? It is moving along negative x-axis. This was the method you have to introduce here. Please do notice it's a very important. I'll put a red color. I have yellow color. No, I'll just highlight that pi so that it will be easy for you. That it's a reflection due to phase change. Okay, we did for what, like third one. So we'll go for the wave moving along positive x-axis. We'll take it. We'll see what conditions will come. Sine omega t plus kx. So what is this wave? Moving along, sorry, negative x-axis. Okay, no. No, it will be reflected from a rigid end. Will you change anything? Yes, the direction of x I have to change. Omega t minus kx plus phi. So this will become minus a sine. What does it mean? Moving along negative x-axis. This will be moving along positive x-axis. Reflected from free end, we'll see what we'll get it. So what is this moving along? Let me do only sine we did, no? We'll go for cos. So it is moving along positive x-axis. Then after reflection from a rigid one, cos of theta plus phi minus cos theta. Now from free end we'll see what we'll get it. So this is moving along. I just picked up. You can try any other thing also. What happens if the incident wave? So if you want, I'll write YR. The symbols will put it, so that will be easier. Incident it is. Some of you are getting confusion with what do you mean by YR? YR means reflected. YI means okay. Try to see this. I think we should take help of mathematics, no, rather than trying to fight with any other thing. Just take help of the plain mathematics. Nothing to do that one. If a wave moving in one direction, if it changes direction, put negative. That's all. Now, what happens if the incident wave is having some initial phase? Because all these are zero phase, I took it. No. Wave moving along positive x-axis. Anybody? What changes you're going to make it? So I'll stick on to reflected by a rigid end a sign where the direction of motion changes, so minus x. Now why this pi? Why that pi? Because reflected by a rigid end. Then this will become let me take help of mathematics here now. What is a sine? I think am I right? It will be like this. Why that pi? Sine of theta plus phi will be minus sine theta. Then now take negative sign outside, will become a sine kx plus omega t. This one. Please do take help of maths. We don't have any concept. So I think if you look at the books, no, you do have questions. So what students will think that it's a new concept. No, when you learn it, learn systematically. Learn systematically. Spend some time, analyze it. Now there's a, in what direction the wave is moving? Wave moving along positive x-axis. Here, moving along negative x-axis. Let's come for this. YR is equal to, I need space some. Okay, till here, this will be. Now you see this. Sir, reflected by rigid and negative sign now there. Reflected by free and negative sign is there. I think it's all about mathematics here, no? Got the idea? So even if the wave arrives with a phase get reflected by rigid free end, okay, now we are in a better position. We can drawing will be, because I don't think so. They may ask you to draw because sine wave will be continuous, no? Because how to when the shape of the rope will be like a sine wave, when you move one end continuously, it will be sine wave. If you just give a jerk and release, it will be a pulse. Okay, we'll discuss the power of a wave. Some small discussion is there, just like somebody. Already we know mathematics of equations, everything, the power of a wave. Suppose if a wave propagating along